Today's video is on section 1.4 called Continuity. The homework for this section in 1.4 is 1 through 6, 7 through 20, and 25 through 28. On number 1 through 6, I need you to add to the directions another part. There's already 3 parts. The fourth part, part D, I want you to also find f of c. And I'll do an example in today's notes. So the informal definition of continuity or continuous is a function is continuous for all c, which is your x values, where there is no interruption in the graph. So what I have here are some examples. So this graph of f is continuous for all c, all values of c, in other words, all of your x or domain values. This function here is continuous everywhere, has no interruption, except at c. Right there, there's an interruption. I have to jump over that hole. This function here, f, is also continuous everywhere, so there's no interruptions, except at c. Not only is there a hole, there's a jump. So it's not continuous there at c. This function here, it has a hole, but it's filled in down here, but it is still continuous everywhere except at c. So if this hole was filled in, and this hole was filled in, it would be continuous absolutely everywhere. This one here would take a lot more work than that. This has got an actual jump, it's not just a hole. So now let's go into the formal definition of continuity. Definition of continuity. A function f is continuous at some c if the following conditions are met. So I'm just talking about a particular x value. Is it continuous through that x value or not? I'm not even talking right now about the whole thing. So it must satisfy these 3 conditions. Number 1, f of c is defined. That just means f of c exists. There's an answer like 2 or 3 or -4 or 1/2 instead of the words undefined. Number 2, the limit of f of x as x approaches c has to be defined. In other words, you can't say undefined. It has to have some answer. Number 3, it basically says part 1 and part 2 must equal each other, must be the same output. So if this is 2 and this is 3, then 3 fails. If this is 2 and this is 2, then this satisfies, so that means that this function f is continuous at whatever c value. So let's try out a mess of problems. And I'm going to take them right out of your homework since there's quite a bit of homework problems. So in 1 through 6, it's A, B, and C, same directions. In fact, that's an actual problem, number 3. And I wanted you to add part D, f of c. And so your c happens to be 3. Directions. Answer the following. Discuss continuity. So let's answer the following, and then we will do the next part, which is discuss continuity. So the limit of f of x as x approaches 3 from the right. So as I approach 3 from the right, that limit is 0. That's the y output. The limit of f of x as I approach 3 from the left, that's also 0. The limit of f of x as x approaches 3. Well, it's 0 because from the right and from the left, it's the same output. Now let's just evaluate f of 3. It happens to be 1. So yes, right now I am not doing continuity yet. I'm doing some review before we actually do continuity. That's what I'm doing on answering this following. But now it wants me to discuss continuity. What can I say about this f function? F is continuous everywhere except at x equals 3. That's the only place it's not continuous, or in other words, discontinuous. So let's go to the next section. The next section was 7 through 20. It says directions. Just find the limit if it exists. If it does not exist, explain why. So again, I'm not doing continuity quite yet. I'm doing some practicing before I do that. So the limit of x minus 5 over x squared minus 25 as x approaches 5 from the right. Well, I only worry about right and left if there's a graph or a piecewise function. That is neither. I do know if I put 5 in here, that'll be 25 minus 25, and 5 up here, that'll be an indeterminate. So I have to use one of those special algebraic techniques. So yes, it feels like we're doing review, and we are doing some review. Now I'm going to do direct substitution. There's the limit. And yes, I know it says from the right, but it just doesn't matter. It exists. So if it exists, it doesn't matter if I say right and left or I don't put the plus there at all. Number 9. The limit of x over the square root of x squared minus 9 as x approaches negative 3 from the left. Well, if I put in negative 3 and I square it, that's a 9. 9 minus 9 is 0. That's going to be a undefined. So do we have any techniques? Well, I can't factor. There's no multiplying by the conjugate because there's not two terms. That's only one term with the square root. There's no complex fractions. Actually, there's absolutely nothing I can do. So I'm just going to go ahead and substitute in the negative 3 because there's nowhere to simplify that function. So I'm just going to say that this function does not exist. It does not exist. Number 10. The limit of the square root of x minus 2 over x minus 4 as x approaches 4 from the left. Again, from rights and lefts, I really only use that when I'm talking about a piecewise function or a graph. Yes, sometimes algebraically, not quite yet. We don't know about that quite yet. So if I put in my 4, that would give me a 0. Actually, give me 0 over 0, be indeterminate. And I do have an algebra technique that I can use on this. I'm going to go ahead and multiply by the conjugate. Multiplying by the conjugate is where the square root is, and I make it like a difference of squares. First terms, second terms, and change out the middle term. Let's see what happens. I multiply the first, and multiply the last. I'm going to leave this as x minus 4 times the quantity square root of x plus 2. Remember, we didn't do that math. We left it separate. Why? So I can see this factor. I'm going to go ahead and do the limit right now by substitution. So it's going to be 1 over, put the 4 in here. That'll be 2 plus 2 equals 1/4. So the limit exists. It does not matter in this particular problem, right or left. It could matter, not just, it doesn't here. We'll find out when. That'll be coming in a day or two. I know I showed this to you today in class. I forgot I had put it in my notes for tonight. But I'll let you go ahead and see this again. I said I wanted to pause for a moment and talk about the graph, this like new parent function, the absolute value of x over x. And remember, this is how we got this. We cannot use 0. X cannot equal 0. There would be an indeterminate and undefined. But I can use every other value. When you put in the positive over positive, it's positive output of 1, the same number. This one here, it's the opposite. It's a negative. So I believe this was even the example I chose to do in class. You would shift this to the left 3 units at negative 3, and that's where the hole would be, because I cannot use negative 3 here. So let's try even putting in 0. Put in 0, that's 3 over 3, which is 1. Put in negative 5. Negative 5 and a positive 3 is a negative 2. That would be a negative 2. But a 2 over a negative 2 is a negative 1. So this is your f function. Let's go ahead and do one more homework problem. I believe that's all I have. It is. This is a piecewise function. Again, if you notice, I'm not even doing continuous functions yet. F of x is in these two pieces, and it's broken up. You can tell which piece to use by the domain, which x values, which input values. Anything less than 2, I use this piece. Anything greater than 2, including 2, I use this piece. So the limit of f of x as x approaches 2. Well, I can't answer that. I don't know what that limit is. Because it's a piecewise function, I have to make sure from the right and the left, they're both the same. You have to. That's the definition of a limit, from the right and the left. I don't have some pretty picture. This is a piecewise function. And it's broken up at 2. So let's go ahead and, I can't even answer this one until I answer these two. The limit of f of x as x approaches 2 from the left. Let's see, which one is 2 from the left? That's 2 from the left. So that means I have to write the limit. You have to show me which piece you are using. Now I'm going to go ahead and do direct substitution. So from the left, my limit is 2. X approaches 2 from the right. Well, which piece is from the right? This is x is greater than, so this is the piece from the right. So that's the limit of negative x squared plus 4x minus 2 as x approaches 2 from the right, using this piece. Now I'm going to do direct substitution. So it looks as if, even though these two pieces were different, that from the right and the left, they both approach the y output of value 2. They both come together. So therefore, now I can answer this, because I had double check from left and right. The limit does exist, and it is 2. Thank you.